going on, Linear Algebra Bros? Mr. C here, and what we're going to do in this video is use matrix multiplication to find the orthogonal projection of 2, -5 onto the x-axis. So basically, what we need to do is find t sub a of x, where our vector x has the coordinates 2, -5, and our standard matrix A is based on the one provided in the table dealing with orthogonal projection onto the x-axis. Now, based on what's included in the table, the standard matrix A for the orthogonal projection onto the x-axis has first column entries 1 and 0 and second column entries 0 and 0. And we're going to multiply that to the column vector version of the vector x. And after some matrix multiplication, the first entry will be a 2 and the second entry will be a 0. So the transformed version of 2, -5 will have coordinates 2, 0. Now hopefully that makes sense. If we look at this from a geometric standpoint, I'll sketch out the vector x as well as its transform vector. Alright, so here's the vector x. We have to project this onto the x-axis. And meaning we will body slam the vector x onto the x-axis, and the vector that results from that will be in line with the point 2, 0. Right, so there's a geometric argument for our output vector's coordinates. Let's also knock out example 2, where it says use matrix multiplication to find the reflection of 3, 4 about the line y equals x. So again, we're finding t sub a of x, and this is going to involve the operator reflection about the line y equals x. And the standard matrix for that is a 2 by 2. First column entries are 0 and 1, second columns 1 and 0. And that's going to get multiplied to the column vector version of 3, 4. And upon doing the multiplication, we're going to get 4, 3. So the coordinates of the transform vector will be 4, 3 now. And you can sketch this transformation out with this particular vector. Let's do that. 3, 4. There's our vector x. I'm also going to sketch the line y equals x in this. The transform vector has the coordinates 4, 3. Now, if you may recall from a pre-calc or algebra 2 course or intermediate algebra that when we do a reflection across the line y equals x, we just switch the x and y coordinate, and that's actually what happened here with our transformation. 3, 4 turned into 4, 3. Now, if we plot 4, 3, the vector that we can form out of that will be t of x. And all things considered, that does appear to be the reflected version of x when reflected across the line y equals x. Alright, so that's going to do it for the solutions to examples 1 and 2. Let me know if you have any questions. Otherwise, thanks for watching, and I'll see you in the next one.